Hello all, I'm Stephen and I'm here at home, working from home like many of you because of the pandemic situation we're in. So while I was at home I thought, why not put some videos together to instruct how to install the air conditioning system in our Maze shuttles. It seems like an especially good idea because the process itself takes one man 8 to 10 hours to do the install and maybe another 12 hours to do the charging. So it's a really involved process, many different steps. I've made many of the mistakes that can be made, and I'd like to help prevent others from making those same mistakes. So these videos do seem like a good idea. What I'd like to do is to go through the installation process by taking you through one component at a time. First, I'd like to cover the compressors. After I've done that, sort of explain the compressors, how they work, the different functions and components of the compressors. I'd like to then move on to the condensers, then the evaporators, the inverters, the control box, the ducting, the copper piping, and smaller things such as the thermostat. But anyway, there's a lot of stuff to cover, so this will be a series of videos. This will be the first, and so let's get started. The compressors are a really important part of an AC system. They're much like the heart is in the human body. The heart is, of course, pushing the blood. It's the engine that forces the blood through the system so that it can carry the oxygen that it picks up at the lungs to the tissues. And then there's a low pressure side of the heart that allows the blood to return so it can get reoxygenated again. Well, the compressors work just the same way. There is a high pressure port and a low pressure port on these compressors. And they similarly are the engine that forces the refrigerant through the system. And much like we have arteries and veins, the AC system has copper piping that carries the refrigerant to one component to the next. At the high pressure port of the compressor, the copper piping will first carry the refrigerant onto the condenser. And the condenser is where the heat that used to be inside of the cabin of the shuttle is rejected to the environment. From there, the refrigerant goes to the evaporators. That's where more heat is obtained by the refrigerant, and then the refrigerant returns to the compressor through the suction line to the compressor. So without the force of the compressor pushing and sucking the refrigerant couldn't move from one component to the next. So it's really important. It's also a very power-hungry part of the AC system. Other than the fans that really don't require a lot of power that are located on the condenser and the evaporators, the compressor has really the only true moving part. And it requires, each compressor requires 6 to 7 amps. Depending on the conditions, it could be 7.3, 7.5 amps on a really hot day. So we might see 15 amps total between the two compressors combined being drained from the batteries because of them. That's why we've had to add a third battery to support this system. So the compressors, although they're very power hungry, they're extremely important. So here you see the right and left compressor. They're mounted in these drain pans with drain spouts coming out of the bottom. That's a feature that we probably will remove eventually because we're finding that there is little to no ice formation occurring on these units during use. So these drain pans really aren't necessary. Instead, we'll have a solid plate for mounting, and the spout and the pan will be eliminated. These are 10,000 BTU units, each of them, a total of 20,000 BTUs for the system. Each of them operates off of 120 volts, and they have ampacity values individually at 10 amps. You have to be really cautious with these units when they're received from the supplier, since they are pressurized there with nitrogen in an effort to keep moisture from accumulating inside of them. Therefore, whenever we go to hook up our gauges, use torches or any other form of heat on them, or remove Schrader valves from them, we want to make sure that that pressure has been taken off of the unit by releasing it through either a partially open Schrader valve or a partially opened cap. The copper lines that deliver the refrigerant to and from these units are 1/4 inch OD and 3/8 inch OD. The 1/4 inch line is a high pressure line. The pressure typically gets between 200 and 250 psi under normal operating conditions. There is a pressure switch here on the high pressure side, another one on the low pressure side also, but the high pressure switch actually opens up at 400 psi and then doesn't close again until the pressure drops to 325 psi. There's also a access port where we can add our gauges to, and again, both of these ports have Schrader valves inside of them, so it's safe to remove these caps, or in this case the pressure valve, without fear of having any pressure coming out of the unit. There's also a port on the end of the line for hooking the copper line to. We are now removing these mechanical fittings and instead brazing the copper line with silver solder directly to this 1/4 inch line. That procedure will be covered in a later video. One of the problems that we've noticed with these compressors is that when we receive them from the supplier, these high pressure lines are such that the access port and the pressure switch are in very bad positions to add a gauge to, or terminals to the pressure switch. That's because when they are mounted on the vehicle, the side of the rear of the vehicle is very close to this edge, or this edge in the right compressor's case, to these two ports, and therefore it's impossible to actually hook a gauge to this port or terminals to this port because there's simply no room here to do that. Therefore, before they're mounted, what we're doing is we're rotating these two ports around so they're actually facing in this direction and this direction. What I have found works pretty well and is much easier to do than, say, rotating this joint and this joint is taking this 1/4 inch high pressure line out of this one and simply putting it onto this one, and taking this line out and installing it onto this compressor. That actually allows the direction of these two guys here to be exactly where you need them, and it's much easier than rotating these two joints and also that joint. So that's something that I will cover in a later video when we get to that. There's also the low pressure side, as I said, which is a 3/8 inch line. This is the refrigerant line coming from the evaporator. So it has been cooled, and this is actually superheated vapor coming from the evaporator. So what we want to do is we want to make sure it's insulated from its trip from the evaporator back to the compressor, which is why you see this insulation here. Again, we'll be removing these mechanical fittings. And in the case of the low pressure lines, which are also called the suction lines, they will not need to be rotated at all because their position is perfect as it is. There is also an accumulator, which is located here. The accumulator's job is to make sure that no liquids end up inside of the compressor. Liquids can't be compressed, vapors can be. So the accumulator's job is to make sure that no liquids, be it water or liquid refrigerants, end up inside of this compressor. If that happens, it could ruin, destroy the compressor. The pressure inside of these low pressure ports typically is between 50 and 80 psi in our normal operating conditions. Again, if the outside conditions have temperatures that are 100 degrees or more, those pressures can also elevate higher than 80 psi. There is a low pressure switch which opens up at 15 psi and then doesn't close again until 35 psi. Just like the high pressure port has a access port for gauges, so does the low pressure here. And again, there's a Schrader valve here and here, so we're not losing any refrigerant or pressure when we open up, when we try and get access to those ports. The only other thing I really need to describe in any great detail would be the power that operates these guys. They're operated by 120 volts. The hot comes in here at this switch, which is a voltage, an over voltage switch. It protects the unit from over voltage. And again, the hot attaches here. The capacitor attaches to this very front terminal here, and these are all quick disconnect terminals. And the neutral here on the one closest to the stud for the 10 millimeter nut here. Again, these units have an ampacity value of 10 amps, and we're usually running them at about 6 to 7 amps in operation. There's a gasket here that actually seals this cap to the compressor, and since these guys are outside, it's nice to keep the moisture off of these terminals, and that gasket does a pretty good job with that.